Hello everyone, in this video we will be doing exercises 3 through 32 from section 3.1 of Stewart Calculus. We are using the 8th edition. In this section we covered a number of derivative rules. Let's review them quickly. So the first thing we want to remember is that the derivative of a constant function is 0. We have the power rule, which says that if n is any real number, then the derivative of x to the n is n times x to the power of n minus 1. We have the constant multiple rule, which says that if c is a constant and f a differentiable function, then the derivative of c times f of x is the same thing as c times the derivative of f. We also have the sum and difference rule. So if f and g are both differentiable, then the derivative of f plus g is the same thing as the derivative of f plus the derivative of g. And the last thing we're going to use in this section is that the derivative of e to the x with respect to x is e to the x. So for those of you who have read ahead through the book, you might notice that the product rule and the quotient rule, as well as the chain rule, are missing from this section. So some of these exercises are certainly made easier using those rules, but in sticking with the themes of 3.1, we're going to limit ourselves to the rules listed here. So let's get started. Problem 3 is asking us to find the derivative of f of x equal to 2 to the power of 40. So already this might be a little bit of a trick question if you're not used to these kinds of problems, but notice 2 is just a constant and we're raising it to a constant power. So this is just a constant. We know the derivative of a constant function is 0. Therefore, f prime of x is equal to 0. Problem 4 is asking us to find the derivative of f of x being equal to e to the power of 5. And again, e is just a number. 5 is just a number. A number to a number is still a number. So we have f prime of x, again, is equal to 0. Let's move on to problem 5. 5 is asking us to find the derivative of f of x equal to 5.2 times x plus 2.3. So now we're going to start combining a couple of rules. Notice we have a constant times x plus a constant. And we're also going to be using the sum rule here because we have the sum of two differentiable functions. So f prime of x is equal to, let's take the derivative of 5.2x first. The derivative of x is just 1 because we can think of this as x to the power of 1. And when we take the derivative, that becomes 1 times x to the power of 0, but that's just 1. So this is 5.2 plus the derivative of 2.3 is just a 0 because that's a constant. So we have f prime of x is equal to 5.2. Problem 6 is asking us to find the derivative of g of x equal to 7 over 4 times x squared minus 3x plus 12. And again, we're going to be using a combination of the rules listed above. So g prime of x. So we have a difference and a sum. So we're just going to compute the derivative of each term and put it together. So the derivative of 7 over 4x squared. So this is going to be 7 over 4 times 2. Now x to the power of 2 minus 1 is 1 minus, now let's take the derivative of 3x. So this is 3. And then plus the derivative of 12 is 0. So if we clean this up a little bit, we have 7/4 times 2 is 7 over 2, x minus 3. Let's try problem 7. Problem 7 asks us to find the derivative of f of t is equal to 2t cubed minus 3t squared minus 4t. So f prime of t, and again, we're just going to look at each component and take the derivative. So the derivative of 2t cubed, this is 2 times 3, t to the power of 3 minus 1 is 2, minus 3t squared, so we're going to take 3, again, multiply it by 2. T to the power of 2 minus 1 is 1, so that's t to the 1, and minus once again. Derivative of 4t is just 4. So if we simplify this a bit, this becomes 6t squared minus 6t minus 4. Problem 8 is asking us to find the derivative of f of t equal to 1.4 t to the power of 5 minus 2.5 t squared plus 6.7. So then f prime of t is equal to, so we're going to take 1.4, multiply it by 5, t to the power of 5 minus 1 is 4, minus 2.5 times 2, t to the power of 2 minus 1 is 1, and 6.7 is a constant, so we add 0. And if we simplify this out a bit, we have 1.4 times 5 is 7, t to the 4 minus 2.5 times 2 is 5t. Question 9 is asking us to find the derivative of g of x equal to x squared times 1 minus 2x. So if we were able to use the product rule, this might be a place where we would want to practice it. But since we only have these rules above, let's expand this. So this is the same thing as x squared minus 2x cubed. So then g prime of x is equal to the derivative of x squared is 2x minus the derivative of 2x cubed. So this is 2 times 3 x squared. And if we simplify this a bit, we get 2x minus 6x squared. Problem 10 is asking us to find the derivative of h of u is equal to 3u minus 1 times u plus 2. Again, if we know the product rule, we can use it here, but let's expand this out to use the rules that are allowed for this section. So we have 3u times u becomes 3u squared. 3u times 2 becomes 6u. Minus 1 times u becomes minus u. And minus 1 times 2 is minus 2. And cleaning this up a bit, we have 3u squared plus 6u minus u is 5u minus 2. So then h prime of u is equal to the derivative of 3u squared. That's 3 times 2 is 6. U to the power of 2 minus 1 is just 2. Or 1, I'm sorry. 5 times u, the derivative of that goes to 5, so plus 5. And minus 2, that's a constant, so it goes to 0. So here's the derivative h prime of u. 11 is asking us to take the derivative of g of t equal to 2t to the negative 3 over 4. So this is a good application of the power rule and also the constant multiple rule. So g prime of t, this is equal to 2 times negative 3 over 4 t to the negative 3 over 4 minus 1, but let's write 1 as 4 over 4. So this is equal to 2 times negative 3 over 4, that's negative 3 over 2, t to the power of, so we have minus 3 over 4 minus 4 over 4. So we can simplify this as minus 7 over 4. So the derivative of g is given by negative 3 over 2, t to the power of a negative 7 over 4. Let's move on to problem 12. Problem 12 is asking us to find the derivative of b of y equal to cy to the power of negative 6. In this case, c is just a constant, don't be scared. And we have a function in terms of y. So b prime of y is equal to c times negative 6, y to the power of minus 6 minus 1. So this is just equal to minus 6c, y to the power of negative 7. Let's try problem 13 now. Problem 13 is asking us to find the derivative f of r equal to 5 over r to the power of 3. And in these cases, I want to rewrite the denominator as 5r to the power of negative 3. This makes taking the derivative slightly easier. So then we have f prime of r is equal to 5 times negative 3 r to the negative 3 minus 1. So this is equal to negative 15 r to the power of negative 4. Let's try problem 14. Problem 14 is asking us to find the derivative of y equal to x to the power 5 over 3 minus x to the power 2 over 3. So we take dy dx, and this is equal to 5/3 x to the power 5 over 3 minus 1, I'm going to write it as 3 over 3, minus 2/3 x to the power 2 over 3 minus 3 over 3. And if we clean this up a bit, we have 5 over 3. X to the power 5/3 minus 3/3 is going to be 2/3, minus 2/3. X to the power 2/3 minus 3 over 3 is going to give us minus 1/3. Let's try problem 15. We have r of a is equal to 3a plus 1 squared. If we knew chain rule, this would be a nice place to use it, but instead let's expand this so that we can use the rules given in this section. So r of a, this is the same thing as 3a quantity squared, so 9a squared plus 2 times 3a times 1 plus 6a plus 1 squared, just 1. And maybe as a reminder, if I have a plus b quantity squared, this is the same thing as a squared plus 2ab plus b squared. So let's take the derivative now. R prime of a is equal to 9 times 2 is 18a plus 6. Let's try problem 16. I have h of t is equal to the 4th root of t minus 4e to the t. So the first thing I'm going to do is rewrite this 4th root so that I have t to the power 1 over 4 minus 4e to the t. Let's take the derivative. So h prime of t, this is equal to 1/4 t to the power 1 over 4 minus 1, I'm going to write that as 4 over 4, minus 4 stays the same, and the derivative of e to the t is just e to the t, so this stays 4e to the t. And if we want to clean this up a little bit, this becomes 1/4 t to the power minus 3 over 4 minus 4e to the t. And I'm going to pause for one moment here to erase the whiteboard, and then we'll continue with the problems. Let's try now problem 17. 17 is asking us to find the derivative of s of p equal to the square root of p minus p. And like always, I'm going to rewrite the root so that I have p to the 1/2 minus p. When I take the derivative, I have s prime of p is equal to 1/2 p to the 1/2 minus, I'm going to write 1 as 2 over 2, and minus derivative of p, that's just 1. So if we clean this up a bit, this is the same thing as 1/2 p to the negative 1/2 minus 1. Let's move on to problem 18. Problem 18 is y is equal to the cube root of x times 2 plus x. Oops. So there's two things I'm going to do. I'm going to rewrite this cube root of x as x to the power 1/3, and then I'm going to distribute. This is x to the 1/3 times 2 plus x. And if we distribute, this is 2x to the 1/3 plus x to the 1/3 times x. So we're going to add 1 plus 1 is plus 3 over 3. So this is 2x to the 1/3 plus x to the 4/3. So if we take dy dx, this is equal to 2 times 1/3 x to the power 1/3 minus 1, I'm going to write as minus 3 over 3, plus 4/3 x to the power 4/3 minus 3/3. Cleaning this up a bit, I have the derivative is equal to 2/3 x to the power minus 2/3 plus 4/3 x to the power 1/3. Let's try problem 19. I have y is equal to 3e to the x plus 4 over the cube root of x. And again, I'm going to rewrite this to make our lives a little bit easier. So this is 3e to the x plus 4, and we're dividing by the cube root of x. So we can write the cube root of x as x to the 1/3, and since we're dividing by it, I'm going to make the exponent negative. So 4x to the negative 1/3. If we take the derivative, I have dy dx is equal to derivative of 3e to the x. So if I use the constant multiple rule, this is just going to be 3 times the derivative of e to the x. But the derivative of e to the x is just e to the x. So this is 3e to the x plus 4 times the exponent is negative 1/3 times x to the power minus 1/3 minus 3/3. So if we clean this up a little bit, we have 3e to the x minus 4/3 x to the minus 4/3. Problem 20. We have s of r is equal to 4 pi r squared. So in this case, notice we have a function of r, and we're multiplying it r squared by 4 and pi, two constants. So we can really think of 4 pi as just a constant, one number. So then s prime of r is equal to, the constants are going to stay the same, so 4 pi times 2 from the exponent, r to the power of 1. And if we clean this up, this is 8 pi r. Let's try problem 21. Problem 21 is h of u is equal to au cubed plus bu squared plus cu. Now notice u is our variable here, so u is what we're differentiating with respect to, and a, b, c are just constants, they're numbers. And just because we're calling them a, b, c, doesn't make a difference. We're going to treat them the same as any other constant. So h prime of u is equal to a times 3, so 3a u squared plus 2b u plus derivative of u goes to 1, so this just becomes c. Let's now try problem 22. We have y is equal to the square root of x plus x divided by x squared. So I'm going to rewrite this like we normally do. So first thing I'm going to do is rewrite the x, or the square root of x, as x to the 1/2 plus x over x squared. And now what I'm going to do is write this as two fractions, x over 1/2, or x to the 1/2 over x squared plus x over x squared. And using my exponent rules, this is x to the power of 1/2 minus 2 plus x to the power of 1 minus 2. So this is x to the power of 1/2 minus 4/2. All I did was rewrite 2 using a common denominator, plus x to the 1 minus 2, that's negative 1. And after some simplification, this is x to the power of negative 3/2 plus x to the power negative 1. So once it's written like this, it's pretty easy to use our power rule. So we have dy dx is equal to negative 3/2 x to the power minus 3/2 minus 2/2 minus, which is going to come from plus minus 1. So minus x to the minus 1 minus 1. After some simplification, this becomes minus 3/2 x to the power minus 5 over 2 minus x to the power negative 2. Let's move on to problem 23. We have y is equal to x squared plus 4x plus 3. And we are dividing this by the square root of x. So I'm going to use the same techniques done in problem 22 to simplify this. So this is x squared over x to the 1/2 plus 4x over x to the 1/2 plus 3 over x to the 1/2. So this is x squared minus 4 over 2. Or I really should write this as 2 minus 1/2, my bad. Plus 4x to the 1 minus 1/2 plus 3x. We can really think of there being an x to the power 0 here. So 0 minus 1/2, that becomes negative 1/2. And if we simplify this out, this becomes x to the 1.5. Maybe we should write this instead as 3 over 2. Plus 4x to the 1/2 plus 3x to the negative 1/2. And now taking the derivative is not so bad. So we have dy dx is equal to 3/2 x to the 3 over 2 minus 2 over 2 plus 4 times 1/2 x to the 1/2 minus 2 over 2 plus 3 times negative 1/2 x to the minus 1/2 minus 2 over 2. And if we simplify this, we get 3/2 x to the power 1/2 plus 2x to the negative 1/2 minus 3 over 2 x to the minus 3 over 2. Once again, I'm going to pause for just a moment and erase the whiteboard. All right, let's now move on to problem 24. We have g of t is equal to the square root of 5t plus the square root of 7 divided by t. I'm going to rewrite this as the square root of 5 times t to the 1/2 plus the square root of 7 times t to the power negative 1. So then g prime of t is equal to the square root of 5 times 1/2. That's the square root of 5 over 2. T to the power 1/2 minus 1 is negative 1/2. And we have plus the square root of 7 times negative 1, so minus square root of 7. T to the power minus 1 is minus 2. Let's move on to problem 25. 25, we have j of x is equal to x to the power 2.4 plus e to the power 2.4. So j prime of x is equal to, so x to the 2.4, we have 2.4. X to the power of 2.4 minus 1 is 1.4. And remember, e is just a number, 2.4 is just a number. This is a constant, so its derivative is 0, plus 0. Let's try problem 26. We have k of r is equal to e to the r plus r to the e. So k prime of r is equal to, well, the derivative of e to the r with respect to r is still e to the r. And derivative of r to the power of e, remember e by itself like this is just a number. So this is plus e r to the power of e minus 1. Let's try problem 27. We have g of q is equal to 1 plus q to the power of -1 squared. Again, if we were using chain rule, this would be maybe slightly easier. Well, let's expand this out since we're using the rules above. So this is 1 squared, which is 1, plus 2 times 1 times q to the -1, so plus 2 q to the -1 plus q to the -1 squared. So this is plus q to the -2. So then g prime of q is equal to, the derivative of 1 is 0, plus 2 times -1, q to the power of -1 minus 1 is -2, plus 1 times -2 times q to the power of -2 minus 1. So if we put this together, we have -2 q to the -2 minus 2q to the -3. And of course, we could simplify this a bit more if we wanted by factoring out a 2 and doing some manipulations with the q's, but we can leave it like this, that's fine. 28. We have f of z is equal to a plus bz plus cz squared divided by z squared. Again, a, b, and c, these are just numbers, and we're going to treat them like any other numbers. Once again, I'm going to simplify this by breaking it into 3 fractions and then rewriting the denominator using negative exponents. So this is a z to the -2 plus b, this is z to the 1 minus 2, plus c times z over z is just 1, or z squared over z squared rather. Again, we can simplify this as a z to the -2 plus b z to the -1 plus c. So when we take the derivative, we have f prime of z is equal to, I have -2 times a, so minus 2a, z to the power of -2 minus 1 is -3. I'm going to take b and multiply it by -1, so this becomes minus b, z to the -1 minus 1 is -2. And the derivative of c, this is just a constant, is 0. So if we want, we can write plus 0. Problem 29. We have f of v is equal to the cube root of v minus 2v e to the v over v. So let's rewrite this as v to the 1/3 minus 2v e to the v divided by v. This is the same thing as v to the 1/3 over v minus 2v e to the v over v. The v and the v, those divide to 1. So this is equal to v to the 1/3 minus 1, so minus 3 over 3, minus 2e to the v. So this is v to the minus 2/3 minus 2e to the v. So when we take the derivative, we have f prime of v is equal to minus 2/3 v to the minus 2/3 minus 3 over 3 minus, we have 2e to the v, the derivative is just 2e to the v. If we clean this up, this is minus 2/3 v to the minus 5 over 3 minus 2e to the v. All right, we have 3 problems left. Let's move on to problem 30. Problem 30, we have d of t is equal to 1 plus 16t squared over quantity 4t cubed. And once again, we're going to want to simplify this a bit. So let's write this as 1 over 4 cubed. And I'm dividing also by t cubed, when I'm going to bring this outside and write it as t to the -3 plus 16t squared is the same thing as 4t quantity squared. And I'm dividing it by 4t quantity cubed. So we can simplify this once again as 1 over 4 cubed. Oops. So 1 over 4 cubed t to the negative 3 plus, and we're left with 1 over 4t in the denominator, but I will write this as t to the negative 1. So we take the derivative, d prime of t is equal to 1 over 4 cubed, that's 1 over 64, times negative 3, t to the minus 3 minus 1 is minus 4, plus 1/4 times negative 1, t to the minus 1 minus 1 is minus 2. And after some simplification, this is just minus 3 over 64, t to the negative 4, minus 1/4 t to the negative 2. Let's do problem 31. Problem 31 is saying z is equal to a divided by y to the power of 10 plus b e to the power of y. Once again, a and b are just constants. So if I take dz dy, this is equal to, remember this is a over y to the 10 is the same thing as a times y to the negative 10. So minus 10 a y to the minus 10 minus 1 is minus 11, plus b, derivative of e to the y with respect to y is just e to the y. So b e to the y. And our last problem, 32. We have y is equal to e to the x plus 1 plus 1. Now, if we know chain rule, we could certainly use it here, but let's rewrite this so that we can use the rules listed above. So this is the same thing as e to the x times e plus 1. We can even write this as e to the 1 if we would like. So maybe writing it again, this is e to the 1 times e to the x plus 1. So in this case, e to the 1 is just a constant. So we're going to treat it like 1. So when we take the derivative, we have dy dx. We have e times e to the x. The derivative is just e times e to the x. And derivative of 1 is 0, so plus 0. And we can simplify this as e to the x plus 1. And that gives us the solutions to exercises 3 through 32 in section 3.1 of Stewart Calculus. Thank you so much for watching this video, and feel free to leave suggestions in the comments for other exercises that you would like to see. Bye.